2018 Exam 1 Matrices Question 1. Okay, this is an allocation problem, and we know that because it said allocation. And allocation problems normally involve a bipartite graph. So maybe if we just draw that bipartite graph out, we can talk about what we're trying to do. And when we're doing a bipartite graph, and you've got Annie, Buddy, Buddy, whatever you want to call them, I'm going to call them Buddy. You have A, B, C, D, and then we've got 1, 2, 3, and 4. We're trying to give everyone one job, and we're looking for the lowest total. So the Hungarian algorithm is just a way to find that lowest total. All right, you don't have to do Hungarian, but that's what the Hungarian is doing for us. And it says here they've actually given us an allocation. So the supervisor has given an allocation, and he said task 1 goes to Dorothy. So 1 and D are connected like that. Now task 2 is going to Annie. And task 3 is going to Buddy. Oop. And, well, by elimination, task 4 must go to Chuck. Like so. And so if they've given an allocation, if the supervisor's given an allocation, then that must be the lowest total. So if we actually do that, we can see that Annie got task 2, Buddy got task 3, Chuck got task 4, and Dorothy got task 1, which means 4 plus 3 plus 3 plus 2, which equals 12, is our lowest total. All right, now what we're looking at here is we've got to compare different combinations, all right? And those combinations could be similar or different. Now, if I was to consider this pair compared to this pair, so we've got a red allocation, and I'll just show, like, we're not changing any of the other parts of the allocation, so I'm going to still keep these two the same, but we've got a slightly different allocation here. And so if we look at Dorothy still gets number 1, and Annie still gets number 2, but we had to swap a pair. So instead of B getting 3, B has got 4, and instead of C getting 4, C is now getting 3. So we just swapped a pair, and that's what I'm trying to show with these arrows on these things. So now if you look at the green one, we're saying 4 plus 3 plus 9 plus K equals something we don't know. But remember what we said, we're looking for the lowest total. Well, 3 plus 2 compared to 9 plus K, which one is going to be better? Well, obviously 3 plus 2 is 5, and you've already got a 9 there. So 9 plus K does not work, does it? So we know that the green one doesn't work. All right, so the green one, which I'm going to delete, doesn't work. Can't be lower. For any value of K, we are going to get a value bigger than 12. All right. And we want to make sure that we're still getting things right. Let's try another color. Let's try purple. So purple, we're going to try swapping another K. So here we got K here and 8. So we're swapping Annie and Buddy around. So this pair compared to this pair. Feeling a bit like a meerkat at the moment. So if we were to draw that out, so Dorothy still gets task 1, but this time task 2 is going to Buddy, and task 3 is now going to Annie. So you can see we've swapped A and B over, and we've left D and C alone. And so we've still got this one, and this one is still the same. So that means our total now is 4 plus K plus 8 plus 2 equals some number. Well, let's compare that. We've got 3 plus 3 compared to K plus 8. That's the arrow pairs. So there's your 3 and 3 and K and 8. And obviously 3 plus 3 is 6. We've already got an 8 there. So it's not going to work, is it? The purple combination, the purple allocation, cannot actually get us the lowest value. Now, obviously I'm doing this quite slowly. In real life, you do it much quicker. but I just want to go through this slowly. You probably won't get a question like this ever again on an exam, but if you understand this question, you're probably able to do this question, any allocation problem on an exam. So our last one to check out is this pair. We got this pair here, which means we keep this one the same and we keep this one the same, and we're swapping the red pair for the blue pair. So let's put our blue arrows in. So now we're saying Buddy gets task 1, and Annie still gets task 2, and we've got Dorothy now gets task 3, and Chuck still gets task 4. So we swapped over between Dorothy and Buddy with tasks 1 and 3. So our totals, if we look at the B ones, is going to be K plus 3 plus 5 plus 2 equals something. And so the ones we've swapped here, we've got this and this. So it doesn't look that easy to see, but we've got 7 compared to K and 5. Now this is the first time that we can actually see that the value is lower. So we can have values for K that will give us the right allocation. So think about this, which is the best way to approach questions, thinking about them. If K was in fact 0, right? You'd have 0 plus 3 plus 5 plus 2, which would be 10. Now that means this is wrong, because that would mean that the blue allocation was the lowest total, and then the red allocation would be wrong. So we can't use 0. What if instead of K we put 1? Then our total would be 11, which means still the blue would be less than the red, and the factory supervisor allocated wrongly. Now let's try then, what if K equaled 2? So 2, that would give us a total of 12. Well, now this means the factory supervisor could have chosen the red allocation or the blue allocation. And so either answer would have been fine. So we can say C is okay. Now what would happen if he had chosen D3? Then the red allocation is the best allocation. But why does that make D wrong? Because when K, we want the least value of K. There's that least word in there. So that's why D is wrong. And by the same logic, you would get 14 if you used K equals 4. So the least value of K, that means that the allocations are not affected, is when K equals 2. Because if you do K equals 2, then you've got 2 possible allocations. And in this case, the boss chose the red one. He could have chosen the blue one, but he decided on the red one.